I'm in Australia investigating Fitzroy River now appears to be empty cane toads.
Let's start by taking a look at why they're disappearing.
Australia was once a buffet, and the cane toad was the only one invited. But the menu just changed, and the waiter is carrying a scalpel. For 90 years, this toxic invader ruled the outback, killing predators on contact. Now, toads are vanishing across Australia, and scientists say something precise is hunting them. What changed, and why now? Is this nature's revenge, or a hidden human intervention? How did 102 toads become 200 million, and what broke them today? The 1935 blunder, the arrogance of man. If you want to destroy an ecosystem, start with a good intention and a box of 102 Hawaiian toads. Let's rewind to 1935, when Australia had a problem that seemed simple on paper but was quietly spiraling out of control. Sugarcane farms in Queensland were under attack by beetles. These insects were chewing through crops, cutting profits, and frustrating farmers who needed a fast solution. So scientists and officials looked overseas and found what they thought was the perfect fix: a tough, hungry amphibian from Hawaii that was already used to fighting similar pests. Sounds smart, right? A natural solution to a natural problem. But here's the question no one asked properly. What happens when you import a species into an ecosystem that has never seen it before? Those 102 cane toads were brought in with confidence. There was no fear, no hesitation, just belief. The idea was simple: release them into the fields, let them eat the beetles, and save the crops. Problem solved. But nature does not follow human plans. It writes its own script. And this one turned dark very quickly. Here is where it gets almost unbelievable. The beetles they wanted to control lived at the top of tall sugarcane stalks. The toads they released live on the ground. So imagine this for a second. Who thought a ground-hopping toad would climb a 3-meter plant to catch a beetle sitting comfortably at the top? That mismatch alone should have been a red flag, but it was ignored. Instead of solving the problem, the toads simply looked around and found something better. They started eating everything else they could catch. Insects, small animals, anything that moved. And unlike native species, they had a secret weapon. Their skin carries a powerful toxin. Any predator that tried to eat them often died within minutes. And just like that, Australia didn't gain a helper. It created a walking chemical weapon. At first, the spread seemed slow, but cane toads breed like a system that forgot to install limits. A single female can lay tens of thousands of eggs at once. Now imagine that happening again and again, across rivers, wetlands, and forests. Within decades, those 102 toads didn't just survive. They exploded into a population of over 200 million. They moved across northern Australia like a silent wave. And wherever they went, the damage followed. Native predators had no idea what they were dealing with. Crocodiles, snakes, quolls, and even large lizards tried to eat them and paid the price. Entire local populations of predators collapsed because they made one fatal mistake. They treated the toad like normal prey. This is where the story shifts from mistake to catastrophe. Because once an invasive species settles in, removing it becomes almost impossible. By the time scientists fully understood what was happening, it was too late. The toads were no longer contained. They had adapted to new environments, survived harsh conditions, and kept spreading further west. Recent studies even showed their devastating impact, reaching regions like the Pilbara, where ecosystems that had never faced this kind of threat suddenly had to deal with it. And here's the part that feels almost surreal. The original problem, the beetles in the sugarcane, was never truly solved by the toads. The entire operation failed its main goal, but succeeded in creating one of the most destructive invasive species in modern history. So now, the real question is not just what went wrong, but why it was allowed to happen in the first place. Was it overconfidence, lack of understanding, or simply desperation to fix a problem quickly? Think about it. One decision, one shipment, one release. And it changed an entire continent's ecosystem for nearly a century. Can you think of a bigger human mistake in environmental history than this 1935 experiment? Or is this the ultimate example of how good intentions can spiral into something uncontrollable?
It's very big. Before the search began, I took the precaution of checking my hands for any cuts. Getting any cane toad poison into my bloodstream could trigger a fatal heart attack.
Because, for decades, the cane toad seemed unstoppable, untouchable, protected by its own poison, with no natural predators strong enough or adapted enough to fight back. Or at least, that's what everyone believed. But evolution has a strange way of rewriting the rules. Somewhere in the wild, something began to change. A predator emerged that did not fear the toxin, something that could bypass the toad's only defense, like it wasn't even there. And when that happens, when your only weapon stops working, the entire game flips. So what happens when a predator is born that literally cannot feel your only weapon? The Silent Avengers, the meat ant army. Evolution just found a biological hacker, and it's no bigger than your fingernail. For decades, the cane toad looked invincible. Its toxin shuts down hearts. Its population kept growing, and every predator that tried to fight it lost. But nature does not accept permanent winners. It studies, it adapts, and sometimes it sends something so small you almost miss it. Now picture this scene: a quiet water's edge in northern Australia. Night falls, the air cools, and thousands of tiny cane toad babies, fresh from the water, begin their first journey onto land. They are small, soft, and completely unaware of what is waiting, because this is where the battlefield has quietly shifted. In 2025, scientists and conservation groups started noticing something strange. In certain areas, especially in places like the Kimberley, cane toad numbers were not just slowing down. They were collapsing at the earliest stage of life, not from disease, not from the weather. Something was picking them off with precision. And here is where the story takes a turn that sounds almost too simple to be real. They used cat food. Yes, actual cat food. Researchers placed small amounts near water bodies where baby toads gather. The goal was not to attract the toads. It was to summon something else, something already living in the environment, something that had been ignored for years. Meat ants. What if the real weapon against one of the world's most toxic animals was already there, just waiting for the right signal? These ants are not random scavengers. They are organized, aggressive, and incredibly efficient hunters. When the scent of food hits the ground, they respond fast. Within minutes, the area becomes a moving carpet of tiny bodies, each one acting like part of a larger system. Now imagine being a baby cane toad in that moment. You crawl out of the water, following instinct, expecting the world to behave the way it always has. But instead, you step into a zone filled with enemies. And here is the part that changes everything. The toad's poison does not work on insects. This is the loophole, the crack in the armor that no one paid attention to for decades. Cane toads evolved their toxin to stop vertebrates, animals with complex nervous systems like mammals, birds, and reptiles. But insects do not react the same way. The chemical defense that kills a crocodile means almost nothing to an ant. So when the ants attack, the toads have no answer. And it gets worse. Baby cane toads have a defense strategy. When threatened, they freeze. It works against many predators because staying still can make them harder to detect. But against ants, this strategy turns into a fatal mistake. What if your only defense was to stay still? While your enemy doesn't need you to move to find you, the ants swarm. They bite. They overwhelm. And because they work as a group, the outcome is almost guaranteed. One ant is nothing. 1,000 ants are unstoppable. Field trials started showing shocking results. In areas where these methods were used, massive numbers of young toads were wiped out before they could grow. The population was being cut at the root before it had a chance to explode again. And this was not just theory. Indigenous ranger groups working on the front lines began using these techniques in real environments. They understood the land. They knew where the toads gathered. And with simple tools and careful timing, they started turning the tide. This is where the story flips from humans causing the problem to humans finally learning how to work with nature instead of against it. Because, think about it, no chemicals, no expensive technology, just understanding the system and using what is already there. So now the question becomes bigger than just cane toads. If a tiny insect can bypass a defense that stopped entire predator populations, what else in nature are we underestimating right now? And here is something even more interesting. This method does not just reduce numbers randomly. It targets the most vulnerable stage of the toad's life cycle. It stops the next generation before it begins. That means fewer adults later, fewer eggs, less spread. It is not loud, it is not dramatic, but it is effective. And sometimes, the quietest solutions are the ones that change everything. But let's be real for a second. As clever as this is, it is not a complete solution. Ants can dominate the shoreline. They can destroy thousands of baby toads, but they cannot hunt everything. They cannot chase. They cannot take down the giants. Because out there, along riverbanks and wetlands, there are still full-grown cane toads. Some weighing close to 2 kilograms, thick-skinned, fully loaded with toxins. Creatures that have survived everything thrown at them for decades. So while the next generation is being cut down early, the old guard is still standing. And that brings us to the next mystery. If ants are handling the babies, then what is taking out the monsters? What is hunting the fully grown cane toads that once ruled without fear? The surgeon of the river, the Rakali's revenge. Meet the only animal in the world that performs open-heart surgery with its teeth. At first, scientists thought they were looking at random deaths. A few cane toads here, a few there, lying near riverbanks. But when they got closer, something felt off. These were not normal kills. There was no tearing, no messy struggle, no sign of panic. Instead, the bodies looked almost precise. What if the toads were not just being hunted, but carefully taken apart? Researchers began documenting what they were seeing, and the pattern became impossible to ignore. The toads were flipped onto their backs. A small opening was made in the chest, and the heart, the most nutrient-rich organ, was gone. Everything else was left behind. No poison triggered, no predator dead nearby. Just a clean, targeted removal. It looked less like a feeding and more like a procedure. So the question hit hard. What kind of animal knows exactly where the danger is inside a toxic body and avoids it completely? The answer came from the water. Hidden along Australia's rivers and wetlands lives a native animal that most people rarely think about. It moves quietly, mostly at night, blending into the edges of streams and muddy banks. To many, it is just another rodent. But this one is different. The Rakali, also known as the Australian water rat. And what it is doing is nothing short of unbelievable. Because this animal has figured out how to turn one of the most poisonous creatures in the country into a safe meal. The cane toad's toxin is stored mainly in glands behind its head and within its skin.
So where is that poison located? It's actually in the parotoid gland. You see that large bump right behind the eye there? So this gland contains a white sticky substance with a very powerful toxin in it.
Bite the wrong place, and you are done. That is what killed so many predators for decades. But the Rakali does not make that mistake. It goes straight for the chest. With sharp teeth and careful positioning, it opens the toad's underside, avoiding the toxic glands completely. Then it removes the heart and sometimes the liver, eats what it needs, and leaves the rest behind. No trial and error, no hesitation, just precision. And here's where it gets even more interesting. This behavior is not random, it is learned. Scientists believe this is a form of cultural knowledge. One Rakali figures it out, then others pick it up by watching or through repeated exposure. Over time, the behavior spreads within the population. It is not instinct alone. It is information being passed down. Think about that for a second. Humans spent decades trying to control cane toads. We used traps, fences, chemicals, and large-scale programs. And yet, this small river predator quietly solved the problem in its own way. How did a rat learn what humans needed almost 90 years to figure out? When researchers returned to the same riverbanks night after night, they kept finding the same signature. More toads opened the same way. Hearts missing. Bodies left behind like evidence at a crime scene that keeps repeating. It became clear this was not a one-time event. It was a system. And just like that, the so-called unstoppable cane toad had a new problem. Not a predator that fights its poison, but one that simply ignores it. This is not brute force. This is a strategy. What makes it even more powerful is where this is happening. These riverbanks are hotspots for cane toads. They come to drink, to hunt, to rest. It is their territory. But now, it is also the Rakali's hunting ground, and the balance is shifting. Indigenous ranger groups have also been observing these patterns closely. Working in the field, they are seeing the same signs. Toad populations that once dominated certain areas are starting to show cracks. Not wiped out completely, but reduced, controlled, challenged. And this is the first time in decades that the cane toad is no longer the uncontested ruler of these ecosystems. Now, let's pause for a second and really think about what this means. You have ants handling the babies at the water's edge. You have Rakali targeting the adults with surgical precision. Two completely different strategies, both exploiting weaknesses the toad never evolved to defend against. It is not one big solution. It is a combination of small, smart ones. So now, the question shifts again. Does the thought of a surgeon rat make you respect nature more, seeing how it adapts and solves problems on its own? Or does it give you that uneasy feeling, knowing something out there is precise enough to turn a toxic predator into a clean meal? Because either way, one thing is clear. The cane toad is no longer untouchable. But even with ants and Rakali working in the background, there is still a bigger challenge. The toads are tough. They travel far. They survive harsh conditions. And they always come back to one thing: water. They need it to live, to breed, to spread. And that is exactly where humans are now focusing their next move. Because while nature provides the surgeons, humans are quietly building something else. Not a wall you can see, but one you can feel the moment you need it most. A barrier made of thirst. So what happens when the one thing an invasive species cannot live without suddenly becomes controlled? The Great Bust, 200,000 deaths in 7 days. The riverbanks were already changing. Ants were swarming the babies. Rats were performing precision strikes on the adults. Nature had quietly switched sides. But then something even more unexpected happened. Humans joined in. In November 2025, Australia stopped being polite and started a war. And not the kind of war you imagine with tanks and uniforms. This one had gumboots, headlamps, buckets, and a strange kind of excitement in the air. Because suddenly, everyday people became hunters. Families, students, retirees, entire communities stepped out at night with one mission: find the cane toads, catch them, remove them. And what happened next shocked even the scientists watching. In just 7 days, nearly 200,000 cane toads were wiped out. Let that sink in. Not over months, not over the years. 1 week. This wasn't random. This was organized, strategic, almost like a coordinated takedown. And at the center of it all was something surprisingly simple: a lure. Scientists and conservation groups had figured out a powerful trick. Cane toad tadpoles are drawn to specific chemical signals released by their own species, almost like a scent that says, "Hey, food is here." But here's the twist. Instead of food, they found traps. These pheromone lures pulled thousands of baby toads into controlled areas where they could be removed before they ever had the chance to grow into toxic adults. It was targeting the invasion at its weakest point. Cut off the next generation, and the future collapses. And it worked. Across regions, teams reported massive drops in tadpole survival. Entire breeding cycles disrupted. Rivers that once crawled with life suddenly felt quieter. But the real story wasn't just the science. It was the scale. Because this wasn't a lab experiment hidden behind closed doors. This was happening in the open, in neighborhoods, in wetlands, in places where people live and walk every day. Volunteers showed up in numbers no one expected. Some treated it like a mission, Others turned it into something almost social. Night after night, people went toad busting. Yes, that's what they started calling it. Groups would head out with torches, scanning the ground for movement. The glow of eyes in the dark. The slow, heavy hop of an invader that had ruled for decades without fear. And for the first time, the balance shifted. The hunters became the hunted. You can almost picture it. A quiet night, the sound of insects, then footsteps, light sweeping across the ground, and a toad freezing, thinking its usual trick will save it. But this time, it doesn't. Because humans learned the pattern, and once humans learn something, they scale it fast. This is what makes the 2025 results so important. It proved something bigger than just numbers. It proved that the invasion is not unstoppable. For years, cane toads spread across Australia at an incredible speed, sometimes moving up to 60 kilometers a year. That's like a slow-moving wave that never stops coming. So the idea of removing them felt almost pointless before.
This is the cane toad, introduced to Australia 70 years ago. Now there are millions, and according to local environmentalists, they are changing the balance of the ecosystem in northern Australia.
Like trying to empty the ocean with a bucket. But now there was a system. Hit the babies with pheromone traps. Let ants handle the eggs and hatchlings. Let rats take out the adults. And then humans step in to amplify everything. It's no longer one solution. It's layers. A full ecosystem fighting back. And when you layer solutions like that, something powerful happens. The numbers start to drop. Not everywhere, not instantly, but enough to notice. Enough to change the story. Because this is what the headlines don't really explain. Cane toads are not just disappearing randomly, they are being targeted from every angle. From creatures as small as ants to communities working together under the night sky. And here's a question for you. If someone told you there was a reward for every toad you caught, how many do you think you could grab in one night? 5? 10? 50? Now imagine thousands of people asking themselves that same question and actually going out to do it. That's how you get to 199,000 in a week. Not luck, momentum. But even with all this, there's a problem. A big one. Because no matter how many toads you remove, the invasion is still moving, still spreading, still pushing into new territory. And that means one thing. Culling alone will never be enough. You can fight them, slow them down, even push them back in some areas. But to truly stop something like this, you need more than removal. You need control. You need to turn the environment itself into a weapon. And that's exactly what scientists and communities are now trying to do. Because the next phase of this story isn't about chasing the toads. It's about cutting off what they need to survive. And the weapon they're building isn't made of steel or stone. It's made of something far more powerful. Thirst. Watergate. The artificial drought. The strategy was changing. Not just chasing, not just killing. Something smarter was unfolding. Because if you can't outrun an invasion, you starve it. The toads are marching toward the Pilbara, but they're about to hit a 150-mile desert they didn't see coming. Picture this for a second. You are moving forward, step by step, night after night. Every few kilometers, there is water. A dam, a puddle, a small artificial pond left behind by cattle stations. For a cane toad, that is survival. They don't need rivers or lakes, just small, scattered water sources to drink, breed, and rest. These tiny pockets become stepping stones, allowing them to spread across massive distances. That's how they've been winning for decades. But what happens when those stepping stones disappear? This is where the game changes from hunting to strategy. Scientists noticed something critical. The toads were not spreading randomly. They were following water. Always water. So instead of fighting the toads directly, they asked a different question. What if we remove the path itself? And just like that, a new tactic was born. Toad-proofing.
A barrier between the Kimberley and the Pilbara. There's a lot of water points in the landscape that have been made by humans. If we can take that water up off the ground and get it away from cane toads, they simply can't survive.
In regions like the Kimberley, man-made water points were modified. Some were fenced off, others were redesigned so native animals could still drink, but cane toads couldn't access them. Same landscape, same heat, but suddenly, for the toads, no water. And without water, a cane toad doesn't last long. This is not dramatic. It is basic biology. They lose moisture quickly and depend completely on regular access to water. Take that away, and their bodies begin to fail. Slowly, quietly, inevitably. Now imagine that at scale. Hundreds of kilometers where every safe stop is gone. No puddles, no dams, no chance to recover. Just heat, distance, and silence. Researchers call this a death zone. Not because something is attacking them, but because nothing is helping them survive anymore. And it works. Field studies show that when these water sources are removed or protected, the spread slows down dramatically. In some cases, it almost stops. Not because the toads gave up, but because they simply couldn't continue. It's like trying to cross a desert with no map and no water. At some point, you don't get defeated. You just disappear. This is ecological chess, and every move matters. But let's ask something real. Is it ethical to create an artificial drought, knowing it will lead to death? Some see it as necessary. Others see it as harsh. So what do you think? Because here's the truth. Humans introduced cane toads, and now humans are stepping in again, trying to fix it. But nature adapts. Always. So is this the end, or just the moment before the toad's next move? The invincibility trap. Evolution's irony. The toad's poison was meant to be its shield, but it ended up being a dinner bell for its executioners.
It releases neurotoxic venom through pinhole openings in its skin. When eaten by a predator, it kills almost immediately.
For decades, the cane toad moved like an untouchable force. It poisoned anything that tried to eat it. Snakes died. Lizards died. Even crocodiles were not safe. It looked like the perfect invasion weapon. No natural enemies, no limits, just expansion. But something strange started to happen. What if the very thing that made the toad powerful also made it predictable? Think about it. When an animal becomes too dangerous to eat, most predators simply avoid it. They do not experiment. They do not learn. They just stay away. That is exactly what happened in the beginning. The toad spread fast because nothing could safely hunt it. But evolution is patient, and Australia is even more patient. Some animals did not run away. They watched. They tested. They learned. You saw it earlier with the ants. You saw it with the water rats. And now, this is where everything connects. The toad created a system where only the smartest, most adaptable predators survived around it. And those predators did something incredible. They figured out the loophole. They learned that the poison is not everywhere. It is concentrated in certain parts of the body. Avoid those parts, and the toad becomes just another meal. Not a monster, not a threat, just food. Now pause and think about what that means. For the first time, the toad is no longer an invader with zero enemies. It has become a food source. And not just any food source, an unlimited one. What happens when you drop an all-you-can-eat buffet into the wild? You change the entire food chain. Predators that once struggled to find food now have a steady supply. Their populations start to grow. Their behavior starts to shift. They hunt more confidently. They explore more territory. And slowly, the balance begins to tilt. The toad is no longer controlling the ecosystem. The ecosystem is starting to control the toad. This is the irony. The poison that once killed everything is now acting like an advertisement. It signals to trained predators that this is a resource worth targeting. It is almost like the toad accidentally painted a target on its own back. And here is the part most people miss. This is not just about survival. This is about pressure. Because now the toad is being attacked from all sides. From below, ants swarm and overwhelm it. From the water, rats slice it open with surgical precision. From the environment, humans remove the water it needs to survive. And from the ecosystem itself, predators are adapting and multiplying. This is not one enemy. This is a full system response. Australia is not fighting the cane toad with a single weapon. It is fighting it with everything at once. So the question is no longer, why are cane toads disappearing? The real question is, how did they survive this long? Because when you look at the full picture, it starts to feel less like an invasion and more like a slow, calculated pushback. Nature did not panic. It adjusted. And now, piece by piece, it is reclaiming control. But here is where things get deeper. Do you think the Australian outback will ever truly go back to how it was before 1935? Because ecosystems do not rewind like a video. They evolve. They change. They adapt to what has happened. Even if the toads disappear tomorrow, the impact they left behind will still echo through the land. New predator behaviors, new population balances, new survival strategies. The outback that exists now is not the same one the toads invaded. It is something new, something shaped by conflict. And maybe that is the final twist. The cane toad did not just invade Australia. It forced Australia to evolve. And in doing so, it may have accidentally designed the very system that is now erasing it. So now the question becomes even more unsettling. Is this the end of the cane toad's story? Or is it just the moment before it reveals one last move nobody saw coming? Will you stand with the silent rangers protecting wildlife conservation in Australia on the ground? Like this video? Subscribe to our channel for more retro survival stories. And tell us what we should investigate next. Feral cats or camel invasion? Change how you see the Australian bush?